Display settings. Show taskbar. No notes. No. Okay. To go back. Sir, someone can tell me like how I can come out of this thing, like only the actual slides.
Okay, anybody can.
Screen. Hide presenter view, something like this. No.
Yep, for you.
Yeah, it's okay. Like, give me 1 second. I will make it a PDF. That will be easy.
Hello, sir. Recording has started. Okay. So,
Sir, 1 second.
Principal, sir, you can introduce if you want.
Just wait. He's making some adjustments.
File. Why it is not going? File. Serious.
PDF. Yes.
This thing. Yeah, maybe something like this is kind of okay. I can go back.
Hello, sir. There is a option in export, file menu export. Please check. You can create the PDF.
Okay. Stop presenting. Sir, now is it visible? Someone can confirm.
Sir, you haven't shared your screen. Okay.
It is.
Now it
Yeah,
is visible.
visible. Yeah.
Okay. Sorry, like
No issue.
working with multiple. Okay. Yeah.
So, thank you, sir. Thank you, sir, for joining. And today's second session is on ethical considerations and future trends uh, by Pardasarthi Beti, sir. He's from University of Agder, Norway.
Yeah. I think.
And already we have introduced him in
Yes.
the first session. And therefore, I request him to directly take over the session.
Yeah. Thank you. Okay. In this presentation, which is spanning about one half, I would like to go at least some 30 minutes about a bit of overview, like what you have gone through in so far FTP, like GenAI, how it is working and everything. And I will touch upon few models as well, so that you will properly understand what kind of future trends are possible with the particular models. And even we will try to see what are the ethical considerations are there with the particular kind of models, like a unimodal and multimodal and text to text models and other AI related stuff, so that it will be go in an easy way. And the last 20 minutes I will dedicate how I use usually this Gen AI and other technologies to do my works, so that makes you a bit uh, more kind of hands-on, which is not possible in this session, but I will try to have a look in those aspects as well. So first thing, before going into actual ethical considerations in a Gen AI, we will try to see what is exact AIGC is doing and how some of the models are doing. So yeah, since many might have come across these kind of stuff so far in FTP. This is one of the famous slide, I could say. This figure showcases the capabilities of Gen AI in image generation using DAL E2 model developed by OpenAI industry. So here, whenever you see, like there are like two examples are being provided. The first image depicts an astronomer riding a horse in a photorealistic style, which is not possible in a space. But this demonstrates the ability of the model to understand a complex instruction and generate an actual visual representation. So this model captures both the astronomical attire and the realistic appearance of the horse, emphasizing its attention to detail and contextual understanding. So in this contextual understanding, we can wonder, like a system is able to understand the exact context whatever we are giving. Like we were asking, making a query of a astronaut riding, and then we are like providing like a horse and in a photorealistic way. Even though it's like the database is not having this kind of photo anywhere, but it was able to generate just because whatever we have seen, the kind of technologies like uh, and encoder techniques, or like sampling techniques, or even database management, and even the the core Gen AI of like transformers and everything is like taking place over here, and it was able to understand the exact context. And even in another example, they were telling like a teddy bear working on a new AI on a moon in 1980s. So even like whenever they were telling like 1980s, so you can see the photo was like a bit of blurred technology, and then the kind of space pixels whatever they are providing, they're not that good. And even more or like it's like a black and white image, and only the teddy bear is having some bit of color. So even in this situation, the system was able to understand, okay, in 1980s the color dominance is not that good, and it was able to understand like there is no too much hi-fi stuff on the teddy bears. And even the systems whatever the computer they were telling, like they were just giving something like AI research. So system was able to understand AI research can be able to done only using the systems like computers. And the current database is having huge number of laptops and everything, but it choose an appropriate computer of the old age era in 1980s. So this is the beauty of the Gen AI. So just by giving a 1980 as one of the key constraint over there, it was able to provide an image pertaining to 1980s, even though the current context is having a huge database. So it was able to see maybe like the old computers and everything may contain like a 1% of database, and the rest of the 99% might contain the kind of laptops, the MXAs, and then very fancy systems, curved displays, and everything. But it was able to choose in a different way. Like it was able to think in a proper way. So this is the beautiful thing happening in a Gen A. So now we will see. I mean, in the upcoming slide, we will see what exact the overview was happening here and how the ethical considerations are being taken place. Yeah. This is pretty much easy thing to understand. Only the system, whatever Gen AI systems are there, they work in two different fashions. One is like a unimodal and then a multimodal. The unimodal refers to like a single modality. So, for example, a text-to-text model receives text as an input and generates text as output. So that is initial version of the ChatGPT. So if you see before the ChatGPT 4.0 kind of thing, before it was working as a totally text-to-text. So it's a unimodal kind of thing. So we are making a query of a text, or like a we are just providing some textual information or like a textual queries, and it was able to generate the text as an output, and it will make a proper summarization or like a translation tasks. And yeah, at that time, DALI came into existence. Even DALI also come with the initial development of like image to image model. So which is like an image to image model might enhance or transform an image based on certain filters or styles. So that was the initial improvement of a DALI, and later they come up with something called multimodal systems and very much specified unimodal systems. This is if you see this is not totally new. Even in this Gen AI, whatever the kind of signal processing we were using, the image processing our was also playing an important role. For example, if you're making some query as a image, and if you're asking for some modifications on the image, like even a removal of a noise is also some sort of unimodal AI, if it is totally being governed by AI. And this kind of model is of very much in use before 2 years, but now people are moving to multimodal systems, where the multimodal is totally in a cross domain. So these models work across the multimodals, accepting inputs in one form and generating outputs in another forms. So here the form, in the sense like it can be of a text or like a image or even a video. Uh, yeah, even sometimes a kind of symbols are kind of appropriate information. So the kind of appropriate information at the input end can excite the system, and it can uh, be able to provide the response of the system in the required status. Like the required status, in the sense it will ask you like whether you want the information to be in a textual form or like image form or like a video form. This is a multimodal system. So the current Gen AI progress is in multimodal. So no longer we are in unimodal systems, and we are in multimodal systems. So if you see, multimodal system exploitation is kind of much easier. Like in unimodal system, the exploitation of system is like a bit hard. Why? Because you need to provide an image. For an image data query, you will be getting an image. For a data query of a text, you have a data query, data output and data input relationships. So in that context, if someone is having a image, then only he can manipulate the system. But whereas coming to modular systems, we are just asking the system like, okay, I want this kind of stuff, which is in a textual query, and we are getting the output as an image. So the kind of content creation is like much easier in a multi-model systems. So the content creation in okay, if you see the content creation over the internet, the majority of the content creation whatever you are seeing, it is in the form of like a huge database, or like a huge data is already dedicated to the videos. rather than the text. That textual information can conveys very small amount of information compared to the image space. And coming to the images, are like much popular and to give the information in a very quick way. And why? Because our senses are like too strong for the image database. All the sort of social platforms we are seeing, we are not too much interested in textual reading, rather than if it is like image reading or like a image context, it attracts the people a lot. So here too much exploitation has been happened throughout the whole database whatever we are seeing, and it is only possible with the Gen AI solutions. That's the one breakthrough I could say in Gen AI, which makes us to allow huge and huge Gen AI content on the platforms. Even if you see in YouTube nowadays, no one is struggling hard to make their things out of it. Like no one was trying to do some reels or something. They can able to make their own demo, or like make their own DP, and make their own system or like some speeches out of it, and then everything was going back end. So even for with by just by telling like, okay, I need to have something like an image I need, and then it needs to have a voiceover. Yes, it's being possible. So here it is happening, and the kind of multimodal which was being trained so far is like too good, and we were like not able to realize it's like a content created by humans, or like the content actually created by the systems. Here we need to understand ethical consideration of one quick point. One is like a human can create an image on his own by using Photoshop and everything. The same thing is being done by a system. So if something is looks like a photoshopped image by human and photoshopped image of a system, we can't able to tell the difference, because even the Photoshop is something like a system manipulated image which was being done by human, and another system manipulated image which was being done by a system. So both the activities, the kind of cursor moving, or like the prompting, or like the image enhancement, all the techniques remains the same. So any image which is like a generated image by human or by system, which is totally uh, unreliable in current era. But there is a few things, a few if the picture is being captured by a human, then some of the details are being missed by multimodal systems. So that's where at least we have a bit of chance to not to exploit the system. So this is the overview, and now we will see how exactly this Geneva is evolved over the time. Okay, yeah. Okay, this is a brief history of how exactly the CV, NLP, and visuals are came into pictures. Like this figure traces the timeline of Gen AI evolution across three domains. Here, I mean to say like three domains in this three domains in the view of. One is like the computer vision, and then another one is like a NLP, natural language processing, and another one is like a vision language. So this history starts with the traditional methods. We know, like far back in 20 years, like we have hidden Markov models, HMMs we usually call, for speech, and even Ngram models for the languages are like much popular. And then the era has seen a bigger breakthrough with the advantage of like recurrent neural networks, and which was later modified to LSTMs just to decrease the computational complexities. And even the LSTMs was like totally changed to GRUs. GRU based things. GRUs enable to processing of longer sequences of text. So this was the actual breakthrough happened in NLPs. The first breakthrough we can see, since RNNs were like very hard to tackle, and even the system complexity was too high, and computation requirements were not that good at around 2014. That time people come up with an idea of having LSTMs, I mean modified RNNs, and then GRUs, which enabled the process of NLP's a significant transformation, which whatever we are seeing, that was the actual breakthrough happened. And then encoding technique and everything makes the transforms bit more easy. And coming to the CVs, the introduction of GANs, okay, somewhere here, GANs in 2014, yeah, even the GANs are like evolved around 2014. GANs in 24 marked a turning point, enabling the creation of high quality synthetic images. GANs was the first one which was trying to do synthetic images for us. And whereas in a vision transformers, we have, it's also a style GAN, usually people used to call, and that makes us a vision language processing a breakthrough. So it's just the kind of progress whatever we are still seeing right now. It's like in 2025, it was just an advancement of last 10 years. So all the breakthroughs of like either NLP or like a vision or like a CV all happened at the same time around 2014. In 10 years, the whole scenario was changed in a different way. Different in the sense like we moved in a very drastic change. Like we came directly to the multimodal scenario by combining all the three technologies together, and we were able to make a good things like this makes a rise of multimodal models like clip. I mean the current versions of like clip whatever we are seeing. Yeah, here it's a vision based one, clips. And whatever we are seeing like the DALI and everything, they brought together the advancements of combining both the NLPs and CV, enabling seamless integration between the text and vision tasks. uh, on a overview, in 10 years, we are able to see to this much progress. And in this progress, we are like too much complicated, and even the exploitation is being started. And so we are expecting like the whole academia industry and all sorts of industries are expecting to exploit more in the next 10 years. And there is like more security concerns there in a multimodal. So let us take one small example. So far, like whenever we are trying to write one paper, like in academia, we used to struggle around in 2014 and everything. We used to struggle a lot in writing the introduction part. So introduction part, if you want to write, you need to really go through the literature survey, and then you need to collect some 20-30 standard papers, and then you have to backtrace what is the actual origin of those papers, and it will all like on comes around 50. And then you have to choose at least 5 to 10 papers which are totally relevant to you, and then you have to write a literature survey just by reading them. And then you have to incorporate the other papers even though they are not totally relevant to you, and like a bit of partial relevance over there, so you have to incorporate them. And then you have to write a 2-page introduction part in a journal paper, which really was taking a hard time for all the researchers. At least it was consuming weeks or like sometimes a months for the people. But nowadays the thing was like so easy. Like we have this textual information PDFs, and if you are able to upload all the PDFs together, and then if you tells like, okay, this is the actual context I am looking at, and this is the paper I am working on right now, and these papers are my relevance, could you please write the introduction part for me? Yes, the whatever the Gen AI technology was there, it was able to do it for us. And even on top of it, we can know whether the content is like from the machine source or a human source. So there are some websites which are okay, just like a plagiarism. In plagiarism, which will tell like, okay, taking the content and pasting the content. And rather than plagiarism, there is called as a AI content. AI content will tell you like whether this content is generated by the AI or a human. On top of it, people were like so good, and in the recent advances, they were coming with another thing called convert AI content to human. There are some websites which will be like, if you give AI content, they will rewrite the things in a human context. I mean, it will make some verb and non-verb kind of alignments, and it won't use too much posh language, and it will take care of the things which looks like a human written language. So this is the advancement of the system. So now we are in an era where we can't able to tell whether the generated text, the given text is totally given by the system or by the human. Why? Because we are able to generate the text from the system, and then again we can ask the same system to make it a human readable, and it should look like a human written language. So this is the kind of context and ethical consideration was being evaluated. And yeah, even making many publications now, right now, even in IEEE and everything forums, they were asking us like, yeah, if you are like, if you are generating few images, or like if you are taking some text using an AI, please kindly specify it. So this is one consideration they started recently in a IEEE transaction on AES, I mean aerospace and electronic systems. So they were asking very straightforward, like if you generated some images, please kindly let us know. Because in AES, the kind of images like the I mean the leader point clouds are like the radar kind of beams or sonar sounds and everything. These things are cannot be captured. Those are like totally EM kind of things. So EM waves we can't capture anywhere. And doing Photoshop kind of thing, or like making EM waves to all together with our own hands and making them color makes it more difficult. But those things can be generated by any AI sources very easily. So they are making this kind of inclusion right now. They are asking, if you use it, please kindly cite it and then provide the details, because they are also not able to validate a few things like whether it's a system generated or human generated. This is the kind of history of Gen AI right now we are seeing, and ethical considerations are more or like starting at this stage. And then yeah, in fewer slides we will try to see what are the future trends we are going to have, and how they are going to apply for different industries and civilian applications. Okay. Now, we will see as an exploitation of a system, how systems are being exploited. Uh, no one was trying to do the systems now from the scratch. Earlier, if someone was working, if I'm correct, if someone is working in a neural networks and everything past before 15, 20 years, if you have to make some CNN model, most of the time people were not having too much access to the libraries and everything. So they were like trying to write from the scratch. Writing from the scratch was actual trend in last 20 years. But now no researcher or like no student was trying to write from the scratch. Why? Because all the things are available in form of libraries, and we are used to have libraries to use. And even now, rather than the libraries, systems are so much trained, and we call them as a pre-trained models, and we are into using the pre-trained models. Even we are not in a position to train our the systems. So we know there exists pre-trained models, and I see model means it can be in a LLM or like even a kind of CNN model or whatever. That doesn't matter. For example, if someone is working on an image space, so they can directly dump the VGG weights. So they can just go to websites and then they can type like I want a pre-trained VGG model. So it will give you all the weights, so that you just need to run it. That's it. So there is no need of training on them or anything. So the model remains the same, and you just make a validation of your data set. So we are in an era of using the pre-trained models and pre-trained systems right now. Yeah, we will talk a bit about like this stuff right now. So this figure categorizes pre-trained LLMs. LLM means large language model into three major types. First thing is called as a encoder only model. Like this example includes BERT models or robot ROBERT models, which are primarily designed for understanding tasks such as classification, sentiment analysis, and even some anomalies. So they excel in tasks requiring a deep understanding of text without generating a new content. So this encoder kind of models, whatever we see, so till now, those are like just to define the deep understanding of the context. I mean text. Or anything, any information, and they are not responsible to generate any new content. Encoder is something like which won't generate anything for us. And we have similarly a decoder models, like model like GPT. Right now whatever we are using, it's a decoder model GPT-3, falls into this category. They are auto regressive, meaning they generate text by word based on predicting the words, making them ideal for generating tasks such as creative writing, dialogue generation, and summarization. So the whatever we are seeing right now in GPTs, it's a decoder model. Already the system was like fine tuned, and they make all the encodings possible at the back end, and they translated the spaces, and they are coming with the weights. So since we are having only weights, we can take the decoder model. So in future, the decoder model is of not that use. Why? Because we don't know the access of the data, like what kind of data was trained upon. So here the GPTs are like a bit of secure models, because they don't have an access to the actual information or actual image set or actual textual sets. So data is not manipulating here in a decoder model, but system is being manipulated here. Gpts are able to provide the information which are more like to our context, but we don't know on what kind of text they really feed upon. So the actual text was preserved, but the intermediate weights text are like the system is only being exploited here. Whereas coming to the encoder models, they know the actual text, uh, I mean actual information or actual image context and everything, but they were not able to generate any generative context for us. And we have encoder decoder models. These combine the strength of both encoding and decoding techniques. Example is like a bot. uh, if you take a GPT wrapper from the internet, which will be useful just to make a query and then get the answer, query and get the answer, you can't really train the system again. But if you take a bot models, these combine the strengths of both encoder and decoder, so they can handle tasks like machine translation and summarization. And even you can make again a retrain of the system. So if you have a new data set and then if you want to train the bot, yes, it is possible. So this is going to have more exploitation from the industry end, and decoder models are going to have more exploitation at a academic and or a academic end. Why? Because we can't have too much data with us. So let us take one small example. uh, there is one industry of a VLSI industry, and we also have courses like VLSI. Uh, and then all of a sudden we decided like, okay, we need to have some, uh, I mean, some CMOS structure or something. And then we'll just ask a decoder, okay, could you please give me a CMOS structure? If the GPT model was already trained, then obviously it will give me a CMOS structure for us, so which can be taken, and like the source file can be taken, and then we can dump it, and then we can do the same process. But what if we don't have? Then GPT totally fails. But if you have a encoder decoder models, yeah, since the model was already trained with too many things, and even if you give some new context information like CMOS, and industry people are having that access, like since they are working in some 10-20 years from the past, so they have the access to their own source files. They'll feed the source files and they will retrain the system, and then they can make it to work for a particular particular context again. So this is the bot model. So if someone is trying to work on a new data sets, totally new data sets, or like a totally new contexts, then I would suggest like the researchers to look into encoder decoder models rather than the decoder wrappers. Decoder wrapper is only for enterprise. Just if your work is being able to done with that one, just take that wrapper and then make it as a product and sell it. But if it is not happening, then go for bot models, and then uh, again retrain it, and then get the things out of it. Yeah. This is one thing. And then okay, we will see like okay, since we have systems, how we can get exploited. Ethical considerations are being done in terms of hardware, so that will be good. Yeah. So whatever the models, whatever we were seeing so far, they were like rigorously trained, and then they are having a huge size, uh, yeah, huge size, and we will just have a glimpse like how exactly they're like done, and then what kind of models are like a bit easy and a bit hard. We'll speak in this slide. This figure illustrates the progression of GenAI models in terms of only sizes and training speeds from it's like around 218 to 223 recent. Like the earlier model, yeah, somewhere switched here, like GPT-2. GPT-2 have a fewer parameters, and which is like around 3 billion, and were trained on a smaller data sets. So that time, that kind of data sets are not included with code and everything. So now GPT version 4 and everything are responsible to give the C code or like a Python code or whatever we make a query. But that time it was totally on a text to text context information. So they were feeded with the PDF, PDFs and everything like the textbooks and everything. So it was able to read the textbooks, but not in terms of code. So the statistics are like the parameters were like staying only around billions. Uh, and and the kind of initial versions of GPT were like very smaller data sets, just because it's a totally proof of concept kind of thing they were trying to do. But over the time, we can see like a GPT-3 or like a BERT large will be there. Yeah, somewhere here, but large, and DALI scaled up significantly with billions of parameters. Now the parameters are like just going too high, and yeah, even if you compare, it's like almost twice with the initial versions. So DALI is around 10 billion parameters, which is too high. And this scaling requires advancements in hardware, such as introduction, which leads to NVIDIA A100 GPUs and everything, and even Google TPUs are responsible to make this work more faster trainings, even as models grow larger. So here we are seeing the trend of the models are going at a higher pace, like in terms of parameters. So that means like the systems are able to learn new language, I mean new information. So the whole sort of new information is being thrown at the system, or like feeding to the system, and making to train again and again, so that it will able to understand. So the first and foremost question we can see here is like whether everyone needs the same model. No is the answer. Why? Because if some student is just working on his class works, and if he is very much aware about like what subject he is really required, so if he is working only in science and he want to do his science assignments, then no need of having systems with these many parameters. So they can totally retrain the system on a very smaller data sets, and then they can get a more accurate information. That is one of the breakthroughs to have models on our phones right now. Many entrepreneurs are coming up with an ideas like, okay, if you want to uh, automate your assignments, yes, we will do it for you. So just give us what kind of subjects you want to have, just download this app. The app will be like only in terms of mbs. So within the mb they're able to do this work, but they will specifically tell like, okay, this app is responsible to do only text to text information within only science genre. So within the science assignments it can able to do. Why it is happening? Why it can't able to do social assignments? Why? Because the system was totally trained with the kind of science. So there is a total durability, total flexibility of the systems for us. So if you're looking for some sort of information or like some sort of particular task, then you can able to develop a system at a very uh, lesser size. Okay, even though the size is going higher, now there are another models like quantizers and everything comes into picture, and even we are having a parameter pruning, or like neuron pruning, and system level pruning, layer level pruning. This kind of pruning techniques are also there, which can make the system uh, to rely on the acceptable levels of a prediction, but with a very lesser sizes. So this is the future. So in future we are going to see too many apps comes into picture. That's a future trend, where every app is responsible to do certain job. And similarly we'll be having a totally dedicated system, or like a which will be like working on a gpu kind of thing, which can able to do a multi-model systems. So the market for the Gen AI is rising in both the spaces. One person will like, okay, take this whole GPU with you, and then it can able to do, which is like in GB or something in that size. They will tell like, okay, this can able to do all your jobs. So it can do text to text, text to image, text to videos, or anything contextual understanding, sentimental understanding, or like a NLPs. It can works like a Siri, or it can works like a bird, or anything can happen. They are at the cost of a size, but which may not allow with the process of our um, phones, because our phones are totally dedicated to 258 GBs, and then lesser RAM capabilities. But they will ask you to like to have a dedicated system which can do, and which can be like a plug and play, which can be totally given to a whole system. So the whole smart home systems can be built, or like a smart interactive homes can be built at a larger models in Gen AI. Whereas for students, academicians, industries, they will come up with a smaller versions of it and in the phones, and which can be done as an interactive module for a humans. This is what exact uh, trend going on. So in this one, which one is like more prone to the ethical considerations, or like more prone to the things? Obviously, if some system is having very huge size and everything, yeah, yeah, it is like a more proner. Why? Because if the system is having too much trained system and everything was there, so obviously people can't train the same system again. So it is going to have more threat, and even adversarial attacks are more possible. Why? Because they are totally training the whole system again and again. So an adversarial data sets are like some bad data sets can also be feeded, and then the system can go into mode of like some ambiguity. But the smaller systems are like very stable, since they are like pertain to the only simple tasks. This is one. And now we will see the architecture. At architecture level, where exactly someone can manipulate the system, or like the system can get into burst, and where the system should be tuned properly to get the best results. We will see this one. This figure actually details the architecture and training pipeline of GPT. This is GPT model. It designed to align AI generated response with a human preferences. This is a simple pipeline. There's three-step pipeline. So first thing is like a pre-training. The model is initialized with a large-scale pre-trained GPT-3 models, which provides the foundation for further fine-tuning. At this stage, the model is capable of generating responses, but they may not align with the human expectations in terms of accuracy, usefulness, and the tone. So whenever you are just making use of a pre-trained model, yeah, it's not that good. So more ethical considerations and everything can be can be kept on these things. But here the content may not be that good, so we can able to distinguish the content from the actual sources. And there is another thing called as a reward model trainings. Reward model training is something like human labelers evaluate the range of model generated outputs for the same prompt and rank them from best to worst. These rankings are useful to train a reward model that encodes human preferences. The reward model predicts how well a response aligns with the human expectations. So if you see in the initial version of the GPTs, uh, if someone really used the GPTs, initial versions are like, for example, if you're asking, could you please tell me what we at the initial stage we were like trying to test the system, only our humans. Even myself, I was asking it like, could you please tell like what is differentiation? It was telling some definition, and then I was giving some question, and it was able to solve. And I know the answer, which is wrong. So then I was telling like, no, this shouldn't be the answer. I know the answer is this one. So why you are doing this thing? So whenever we are re-questioning the same thing to the GPT model, uh, GPT model, it will be taken as a reward. So we know what is truth, right? So we were asking like, no, this shouldn't be the thing. Even I have seen some funny memes and everything in a social platform. They were asking like the straw, how many R's are there in strawberry, and it was telling like a wrong answer, and people were thinking like, no, I am intelligent, I am telling the system was a fault, and we are telling like, no, strawberry have these many R's, and we are thinking like we are so superior than the system. But the actual intention behind is like, system is freely trained by us. The initial GPT models, whatever we saw, we are the people who really worked hard for the GPTs. We are only just giving new content to it, and then we are only just giving a reward to it. No, it is good, thank you. And then we are telling like, no, this is not looking appropriate. So whenever we use this kind of words, I don't think it is correct. So these are called as a rewards. So this kind of reward label is being given to the systems, and then people are people are being used to by the systems very freely, and then the system is upgrading itself. It's not the human upgradation, it's like a system upgradation is being happened. uh, it's like a by paid or unpaid. Unpaidly means we are questioning the system, and then we are correcting the system, thinking like we are very superior. So we worked for their company without having any money, and even they are having a labelers, proper labelers, who will test the system, and they will tell like, no, this should be the correct way. So yeah, in this zone, exactly this zone, very much huge exploitation has been happened. So initial version of a GPTs, people were throwing too much information, too much wrong informations, or like too much unnecessary informations, asking too much unnecessary questions or contexts, and then making the system very unstable. So whenever you are seeing any model which is like a reward model, so reward models are not totally good. Why? Because in a reward model, it is always like a human reward, and the humans are totally what we can tell. We can't predict the human behavior exactly. So if some person likes, that doesn't mean everyone likes. If some sort of people may like uh, too much harsh reality, some people may like very soft spoken, some people may be like too much truth friendly. So the reward is totally defined by the human, which is not able to uh, distinguished by the system. So these kind of models are like very much prone to the actual reality. So the reward model which is being trained by the humans are like not bad. Why? Because a simple person can always throw a bad information at it, and then can make system bad. And there is one more thing called as a reinforcement learning and fine tuning models. Yeah, the model is fine tuned using reinforcement learning guided by the trained reward model. During this process, we usually have PPOs, or we call that as a proximal policy optimizations, is employed to optimize the model's response based on humans' preferences while avoiding overfitting to the particular patterns. Yeah, even in this case, human response was like there, but the human response was like taking into again the mathematical model of a proximal policy optimizations and everything. And then the kind of reward is like soft reward, it is not a hard reward. So they were trying to model the human behavior in that one, and then they are giving a soft reward kind of thing. So the system will learn slowly, but it will learn in a good way. So this is the best model in my opinion. And even in a state of art literature, the reinforcement learning based are like a policy based reinforcement learning in the GPT models are like AI models is the new future, and this is going to rule the world. This is the future we're going to see. And then okay, yeah, here we are. And yeah, this is like a vision generator models, how exactly they follows. Okay, we will see. This figure actually categorizes vision generative models into four types. One is like a GANs, and then variational and autoencoders, and then normalizing flows, and then diffusion models. I hope at least by this FDP, everyone might have come across these words. And now we will see uh, how prone they are, and like what kind of systems are good, and which systems are going to beat in the future. Okay, but I will tell a small definitions before, so that people don't get any ambiguity. This is like a GAN model. GAN consists of a generator that creates a synthetic images and a discriminator is there, and which will evaluate the realism. So in this one, we have like something called style GAN, which separates image style attributes for a more intuitive control, and then big GANs are there, which enables revolution and diversity in generated images. So it's so good. Like we are able to have synthetic images, and then it will only being quantified. So there is no intervention, everything here, and we are able to tell like, okay, it's a real or fake. So the system is able to tell. So whenever you see in future like any anomaly tasks or something are coming into the picture, then GANs may takes place in a good way. So whatever we are talking like is the content is being generated by the system again. So the whole task being done by the system can be evaluated by the system only by using this kind of models, GAN kind of models, because they will only generate, and then they will try to see, and then they will try to tell, okay, this is one kind of model. And yeah, this kind of encoder decoder models, we call them as a uh, auto encoders basically. And then this is one sort of type. Whenever you see p theta and q phi kind of thing, it's like a probabilistic in nature. So it's a probabilistic autodecoders. Probabilistic autodecoders are called variational auto encoders. So now we call them as a variational auto encoders, use the probabilistic model to generate images by learning the underlying data distribution. So they are trying to learn the image distribution, and they are particularly useful for tasks like controlled generation, such as gen gen AI images. So what are the images we are seeing right now in a very good way? They are totally in a probabilistic way. So they are trying to understand the underlying data distribution. So variational autoencoders and its variants are going to be like the future for image generations. And this is a normalizing flows. These models simply uh, relies on the distributions to complex ones through invertible transformations, allowing precise control over the generation process. So even this is also some sort of encoder decoder model. And yeah, this will go in hand to the variation autoencoders. And in normalizing flows can be like more dominant in a future. Why? Because they will see the system like whether the flow and inverse flow are really matching or not. So they will try to see the system is totally really learning or not learning. So this is one area of research which people are trying to exploit right now after variational encoders. And this is one of the popular model called a diffusion model. These models corrupt data with a noise during training and learn to reverse the process of generation. So that is a beautiful thing with the diffusion model. So it is only responsible to corrupt the data, and then it is only trying to train itself, and then learns to reverse the process for generation. So this is the actual part of DAL-E. So whatever we are seeing right now, the DALI networks and everything, the model, those are relied on diffusion models. And these are responsible for creating high resolution images and fine grained details, because the system itself is like being corrupted itself, and then it is being auto generated, and then it is evaluating itself. So yeah, if someone want to do a regressive uh, research on reliability, and then high space, like high resolution images and everything, diffusion models is like the one area. So people can target upon. um, okay, and then okay, this slide, this is a vision language gen models, how they work. It's like a, we have inputs and then encoder model, and then there is a representation or like a g space. It's like a variation of encoder, and then decoder, and then we get the output. This is totally uh, normal flow. But whereas here, like we'll make like, yeah, to text we will see, and then we will try to get the pre-trained encoders, and then we will see the representation is like totally going, and then transform decoder will takes place. So this is actual context, like where we can see it's not totally multi-model thing, but it's not spread over the spaces, but only in one space it is working. Like we are giving something as a text. I mean, we are making a query with the image, and we are making to text, and then again we are seeing the text. So internally even though it works as a multimodal kind of response, but the system input and output relationships stays very straightforward, like text to text relationships. So this is the one thing vision language gen models are right now doing. And even we have cross-aligned encoders and everything. So one encoder model from another model, like the text encoder can be clubbed with vision decoders, and image encoders can be clubbed with text decoder. So this is called as a cross-aligned encoder decoder models, which are actual responsible for multimodal systems, whatever we are seeing right now. Yeah. And then yeah, this is the same. Yeah, this is one diagram which will tells like how exact fields are being interacted, and then how the exact industries are targeting upon, and what are the advancements right now we are seeing. Okay, now we will directly go to something maybe somewhere here, like OpenAI, which is very popular. Whenever you see OpenAI is giving services, like we have different services from OpenAI, which is responsible to give the codecs, I mean, for the code support and everything, and DALI for the images, and then Crayon for the intuitive arts and everything, and then ChatGPT for the chat boxes and text, and then OpenAI is also being connected with the jukeboxes and the music. So all of it. So like if you see OpenAI, its duties are like very much impressive. Like they are trying to do NLPs, music genre, and then they were trying to do the text with the chat GPTs, and then art fields, particularly with the images, everything with the Crayon, and then images and videos at DALI. So, and on top of it, they were trying to make the system, even codex is some sort of textual information, but which is called as a intelligent text representation. So code contains always a proper flow and a proper alignment, and then it is having logic, reasoning, and everything. So even though there is like nothing other field was left by the open AI right now. So whatever the information we have information in only four forms. One is like a pure text, which is being dealt with GPTs and codecs, and then images, crayons, DALI, videos, and then NLPs like a jukebox. So they have total very specific multimodal system. So these open AI can make very good God AI. We call it is a God AI. In Gen AI, the future is like a God AI. It can be developed by the open AI because they spread in all the four directions. And now we will see, like we know only chat gpt, like we academicians use chat gpt more, but rather than chat gpt, if someone is really interested, they can also try Amazon's Alexa, Lex, and then blender bots, even Mina, and even bar, even Google also gave something similarly, Mina, and then DeepMind people also give some other thing. So even the chat bots are like increasing, which works in text to text. And if someone is looking for a totally art kind of thing, like at a image level, DALI and Dream Studios are like best things which will work. And for academicians and students and industries, if they are looking at a code part, obviously code part can be very good by Codex by OpenAI, Copilot by Microsoft people, and then CodeGen. Even CodeGen, I'm not sure how good it is. Like Copilot is kind of very good for coding tasks. And this is some sort of thing. And then we have another one more thing which is being dedicated by a whole sort of very good reasoning and coding, which is called as a algorithm by alpha tensors. You can see from the DeepMind is a people who behind in releasing the alpha tensors, which is going to make algorithms. So recently, 2 days back, they were telling like they were able to develop an algorithms which can model the space and everything. So it's a too much algorithmic interpretation, too much mathematics being involved. But yes, they are able to come up with a alpha tensor models which can able to solve this kind of problems. All our mathematical problems from the textbook or like from our research community, yeah, maybe able to be solved by this alpha tensor. And people are looking to have a cross domain from other peoples as well, like OpenAI and Microsoft people, so that they will also contribute to the algorithm. And in future, I'm not sure, like a system can generate another system. There will be no another diffusion model by the human. Maybe much superior diffusion model can be designed by only with the AI model. So that's the major breakthrough we are going to witness in algorithm. And humans are going to be only end products, like they are going to use the things, will remain as a uses or end products. We may not be able to use too much, but there is an opportunity for people. I will tell one small thing. uh, Around 20 years back, I mean, no, no, yeah, maybe 20 years back, like we used to see this rickshaw and everything, right? And the coming of the autos, people were thinking like there will not be any duty for the rickshaw people and everything. But what happened, like the rickshaw people upgraded to autos just by learning. So it's like upgradation of skill is required every time for humans, for making a total human evaluation. So no need to worry about like some only algorithms are going to develop by the systems, but we should know how to use the system good enough, and we can make the things possible. This is one good thing I could say. And yeah, I say everyone to save this slide if possible, and these things are very much useful in Gen AI and content creation for you. We'll move to next slide here. Okay. Okay, this is just one small table which will tell like, okay, which company launched the actual application and the platform and year, which is very much relevant. And yeah, you people can try to use them as a Gen AI people which who wants to work at a much faster pace. Now, coming to ethical considerations in Gen AI, so Gen AI models can making biases present in the training data. If your training data was not good, yes, it's going to make some bias. And the potential for impact can be only done by reinforcementing. That's one good thing. And this can also make an impact on these kind of departments like loans and criminal justice kind of thing. And Gen AI is also responsible for making misinformation and deep fakes, which is one of the biggest problem right now we are seeing. A generation of misleading content is possible, and yeah, deep fakes are possible. Okay, I will share one news with you. Around some 3 years back, uh, in one of the popular Automatica conference, people were trying to ask the system, like advanced systems. They are asking what you will do to sustain for a longer time. What is your actual plan to sustain a longer time on this earth? And what makes you to dominate humans? It told only very straightforward answer: I will create a fake news regarding the religion, regarding the uh, creed, and color. So these things only, as a humans, we are too much emotional with the religion, caste, creed, and other things. So this is what the actual understanding is there for AI itself was telling like, okay, if I'm able to spread this kind of fake news in terms of relations between the countries or relations between the religions, it will disrupt the whole humankind, and I can sustain myself. So this is the actual understanding of the systems right now. And yeah, fake news is like a biggest threat in a near future. And risk include the spread of false information, reputation damage, and trust. So yeah, maybe in the near future, if someone is having a criminal allegation, it is very highly likely, it's hard to prove whether the document is true or not, the voice is true or not, the image and video context is true or not. So there is like too much trust content and non-trust content issues will come into picture in a judiciary. And for the Gen AI, copyright and intellectual properties, issuing the proper copywriting material is like very much uh, good thing, but what if like a AI generated content is there, and then we should be able to create the ownership to the AI generated only. For example, if we are writing paper with the help of Gen AI, so do we need to give credits to the Gen AI, or do we need to take the credits to ourselves? Why? Because we are the person who was making proper query, like as a prompt engineer, and we are doing it. So the content is like, are we are the actual owners, or like a Gen AI is the owner? So this kind of copyright issues is there. And another ethical consideration is like privacy and data security. So the moment if some researcher is trying to do some paper or something, if he's asking too many questions like, I did my system model like this, and is it good or bad? So even sometimes we get doubt like, okay, I am posing my intelligence to the system, I am telling my intelligence, my kind of thinking to the system. So what if it is really getting plagiarized by some other source? If you're checking if it is a plagiarized, and it's telling like, no, it is not being plagiarized by any source, and we get a doubt, okay, it is already in system now, so your data is no longer secure. Your data is having one copy with it. Okay, this is one of the important things, the privacy and data security. And the systems are lacking with the transparency and explainability. Even we can call from Gen AI transformer, even any model right now we are seeing they are lacking with their transparency and explainability. The concept of transparency and explainability, I feel like it ended up only with the clustering forests, and there itself the explainability of the system stopped. And thereafter we are like dealing whole and soul with the black boxes nature, yeah, which makes this Gen AI systems much trivial, and we don't have too much understanding of the system as well. These are the kind of ethical considerations we have to look into while designing the system. Yeah, anyway, this may not be possible in even in near future. And for an open topic, there is something called settling machines. Settling machines is one group of people who are working on settling machines. AI developers, they are also AI developers. They always work on explainability of the system. So whatever the model gives, they want to make it more explainability sharp. Whatever feature we use in our current models and everything, it's also part of a explainability. So yeah, I feel if someone is working on explainability, they can try to see settling machines sharp and kind of things to develop the machines much explainable. Now the future trends is like this Gen AI is going to make a very good high stake applications in a near future, especially in healthcare, finance, autonomous vehicles. This is going to have happen. And even right now, we were like able to tell like we have seen this kind of thing in a near in the past. Galactica scientific tasks faced criticism for biases and errors. Yeah, this happened only just because it was human errors and everything. So everything there needs to be like a more confidence score, reasoning, and source information for high stake applications right now. And then we need to in the futures we'll be having the specialization and generalization more in this field. We are going to see more diverse data doesn't always ensure better specialization performance. People have to remember this thing. So more data doesn't mean specialized performance. Specialized data will always give a specialized performance. So always try to make your system specific for a single task, so that it will learn the same task again and again. It will do it better. Just like Hussein Bolt. Hussein Bolt is not trained for too many sports. He was trained only for a single sport to run for 20 years, and then he was able to get uh, better of the best of the best people, and he stood less than 10 seconds. So that is how even the systems should be like. A specialized performance always comes with a specialized data. So if your data is like very specific, very good, just be specific to the data and then create your systems. So that's one good thing. and always there will be a trade-off between specialization and generalization in the data sets. So people have to think of it. If people are trying for more multitasks and everything, they will go for generalization, which will degrade the specialization task accuracy. So this is one future topic someone can look upon. So to make a generalization, try to make the specialized tasks more cost and cost effective, and then go for it, or like make a distributed system kind of thing. And continual learning and retraining kind of thing. This continual training and retraining is very much important for the system. Why? Because whenever the new data comes, we are not in a position to retrain the whole system, right? So only retraining is kind of good rather than like a training from the start. So if someone is looking into ML models, I would say people should also touch upon something called reinforcement learning and retraining and de-learning kind of things in particularly ML, DL, and other domains, so that there is a good future for this domain. And reasoning in AIGC. So the kind of advanced AI generated content, whatever we are seeing, uh, there is a lack of reasoning right now. Logical reasoning is crucial for solving complex tasks. So if someone want to work in a generative AI, the future trends should work on a logical reasoning. So that's why, yeah, I was telling like only the logical reasoning was initiated by deep mind people so far. They are not into too much things. The deep mind is trying to go for reasoning things, and even now Open, Microsoft, they will also try to contribute to it. So continual learning and in retraining. And then in the reasoning, people should always think about more reasoning to the system, so that it will try to think like a human. That is one important thing. And yeah, chain of thought and prompting. So whenever, even in our chat GPT and everything, whenever we are asking some question, and if you think the second question is also related to the first question, then I would say please ask it something like, please remember my previous chart, and then please give answer for the following question. So that's how you should try to ask. It's called as a chain of thought prompting. So the prompt should be linked so that system will learn in a good way. And then the promising applications are like a question and answers and code generations in this domain. And there is a very good business over here in scaling up. Scaling models increase data computation and costs, and uh, sometimes dealing with the bigger systems may be not good, because too many hyperparameter tuning needs to be seen. So a suboptimal system and a subsystems are kind of good in a Gen AI right now. So that is why people are just releasing Chat GPT kind of thing, which is a text to text, not in a multimodal. So suboptimal hyperparameter is always the best option in a ML. Okay, and then we need to have better strategies and optimal large scale training in a near future, which is still a bottleneck. And coming to the social issues in a near future, there will be too much bias and ethic considerations for AI generated content. For example, all the AI bots, whatever we are seeing so far, they are like totally very much trained in English. So the kind of query, if you are asking in a Kannada or like some Hindi, yeah, it will get some biases. Why? Because they are not too much into NLPs of our regional languages, so it will create some bias. And potential misuse is also possible in social issues in a near future. And too much deep fakes and misinformation is possible in a near future. So someone can take up research challenges like how these things can be intuitively understand by the system and by us, or like make system to understand. uh, these are the deepfake informations. This is one good thing. And always we should, whenever we build the systems, we should ensure there is a social responsibility on our shoulders. Yeah, yeah, this is yeah, thank you. I'm sorry, like my slide was running. uh, Thank you. Okay. Mm, yeah.
Yes.
Okay, then I will. Yeah. To this extent, if people have seen, right, I will show something interesting. How the ethical things can be done. Yeah. For example, okay. Okay. This presentation, whatever presentation I gave today, yeah, it is totally generated by AI itself. It's not from my own hands. I asked the AI generator to create slides for me, and then I asked it to give me some uh, key points to stretch on the slides. Yeah, and yeah, maybe that's click that's not okay. So that's how I created the slides. It took me around maybe 1 hour to prepare the slides, and for my preparation it took me hardly 1 hour. Why? Because it's a general topic. Ethical consideration of future trends is like a general topic. So for a general topic, if I'm taking 2 hours of time from the system, I mean 1 hour from myself and 1 hour from system, and I was able to deliver a lecture of 1 hour, 1.5 hour, so which is a productive thing. In case if it is like some uh, okay, okay, visualization. If it is something like, for example, auto encoder decoder model, yeah, even whatever auto encoder decoder model I gave 2 days ago, I was asking it like, I want to prepare the slides. Could you please give me how it can happen? And even I was asking like, whenever I was getting a derivation and everything, if I'm getting some doubts, I was taking the help. And even to demonstrate some codes, I was asking like, could you please tell me like. Uh, Give me a quick code so that I can just run in a system. And yeah, even I was asking the system like, please give me a lecture note which can of this much time, and tell me like what exactly I need to understand. So this is the kind of system. So since there is no ethical consideration, like since I'm taking the information and spreading the information, the kind of copyright can be issued to the system. I mean, system itself. Gen AI is the one which is responsible to create the slide. So, but the diplomacy comes here, like who should take the actual uh, I mean, actual rights, like to the presenter, or like the presentation which was generated by Gen AI. So this is a kind of diplomatic situation in ethics and the considerations, and this is the future. I suggest people to try to use uh, Gen AI technology. Gen AI technology. Don't fear of it. Don't fear like Gen AI is going to create the content, and we may lose our options. No, no, no. It shouldn't be the task. It should be reverse way. You should be potentially strong enough, and you should tell yourself like, I am going to use the Gen AI technology for making my job better. So this kind of attitude is very much required for the people. For example, if some teacher was thinking like, for example, let us take two teachers were there. Teachers means some two assistant professors were there. Sorry for that. One was thinking like, it's very hard for me to prepare these many slides and everything. Even if a student can go and ask a query like, could you please explain the transistor, or like some, if you please explain me C code, it will give me the code and everything. He can learn on its own. And he's having an insecurity like whether I am able to deliver lecture to that level. So I'm going to teach from the textbook. There might be a lack of context aware, or there might be some explanation I may not be able to give. But if the same student was making a query in internet, he can get the hell lot of space, and he will end up with the depression. Like I may not be able to reach to the level of a system. And there is another one more professor who will like very confident. He will think like, I know, see, I'm going to teach this one. On top of it, I'm going to take the help of Gen AI so that I will create my slides better. I will take some intuitive examples from it, and I will take the content like images and everything so that people will see and feel the things. And I will take the code from it and code talks and everything, and I can make a hands-on experience for them, and I will make a human touch to the actual system generated information and my own intelligence, so that the class will become a brighter. So this kind of attitude needs to be there for people, and this is what I expect from all the researchers, students, and everyone. may try to use Gen AI, and I'm happy to be part of this FTP program, making a huge success. Yeah, thanks. Thank you. That's the end of my slides and
Yes.
everything.
Thank you, sir. So, any quick questions? One or two participants, if you would like to ask. Okay, fine. Uh, Otherwise, already I think, sir, you have shared your email ID yesterday. Yes.
Yes, yes. Sir, do I need to share the slides?
Yes, yes, yes.
Yeah,
Please.
yeah, okay. I'm doing it.
To my
Thank
email
you.
ID, RR Barney.
Okay. Sir, could you please? Okay, I have your mail ID anyway. I will take from.
RR Barney, I will
Yes,
text.
yes, yes, sir. I have.
Okay. Good afternoon, everyone. Uh, on the behalf of all of us, I would like to extend my heartfelt thanks to the distinguished speaker, uh, Partha Sarthi Beti, for enlightening uh, on ethical considerations in generative AI and future trends. Uh, he provided us with invaluable insights into the challenges and responsibilities that come with harnessing such transformative technology, from highlighting the importance of fairness, transparency, and accountability in AI systems, to shedding light on the future trends as well that could redefine the boundaries of what we consider possible. Your expertise has broadened our understanding, sir. Your words reminded us that the technology is not just about innovation, but also about impact on people, communities, and the world at large. Once again, we deeply appreciate your time, effort, and commitment to this very vital subject. Thank you. Thank you very much, sir.
Yeah, thank you, Bani sir. Yeah, yeah. Thanks for giving an opportunity. First of all.
Okay, thank you. Thank you, sir.
Yeah, I did it, sir. I mailed you.